Okay. So today we've got a problem set to go over, and that would be for chapter 6, which we just finished. And when that's done, if there's any time left, I guess we can take a peek at the next chapter, which is actually 8. Now, I did want to point out here that I have posted on Moodle something new. Let's see what, okay. So anyway, I've mentioned a couple of times the midterm, the first one that is based on 5 and 6. We're now done with 6. We're about to do the problem set. The only remaining hurdle to doing the actual midterm is the so-called sample midterm, which is basically a set of problems from both chapters. And it's designed just to get you ready for the actual test. And you can see it's a little bit shorter than the others that we've been using. Only 10 questions, although there's multiple parts. And this is very, very similar to the actual midterm. Now, unlike normal years, you'll be doing the midterm at home on your own time. And, I found that in the online format, a week is usually sufficient time to give everyone to get it done. It shouldn't take that long because it was originally meant, as I've said before, to be done in a classroom setting in about an hour and a half. So I'm sure you'll be able to manage it. But before we do that, we still have a few more things to do, including this sample midterm. So if you want, in fact, maybe what we should probably do is agree that assuming we finish the problems today from chapter 6, why don't we do this? Why don't we start the sample midterm next Monday? I think that's a good idea. There's no point in waiting. You probably already have had midterms in your other classes anyway. So, it's not that early, especially given that we're having 2 midterms and a final. So probably every 5 or 6 weeks for a test is about right. All right, so let's do that. Now, I do also have one more fun video for us if we get to it today. If not, we can save it for next time. But for right now, why don't we just dive into these problems? And, this will be a good opportunity to make sure you really understand what we've been doing. Some of these are more straightforward than others. Some of them are really easy, and some of them are maybe not so easy. There's a mixture in here, as you can see, of word problems and regular algebraic problems. So let's see how this works. So first, we have a math class with 57 students that was divided up into 2 sections. Now, because there's 57, we can't obviously have the same number in both classes. And it turns out that one of the sections has 3 more students than the other. So how many are there in each of these 2 sections? Now, there's several ways we could go about this. And I'll try to do at least one of each. But I think I know what people prefer based on past experience, which approach everybody likes to take. So why don't we do this? Let's let X be the first class or first section, and then Y can be the second section. And then in that case, we can make 2 statements. First of all, the total is 57. Okay. And secondly, one section has more than the other. It doesn't matter which one has more than the other. It doesn't specifically say that. So why don't we let Y equal X plus 3? All right. In other words, we'll assume that the second section is the larger one. Now, with all this information in front of you, how can we solve for X and Y? Well, you'll see that we have 2 pieces of information. In fact, you may have heard this phrase in high school, 2 equations, 2 unknowns. What that means is that in order to solve for 2 variables at the same time, or 2 unknowns, you must have 2 equations. Now, there's a couple of things you could do here, but the one that I find that most people prefer is the so-called method of substitution. So using the method of substitution, we can replace Y with X plus 3 in the first equation. Okay, so in other words, in the first equation, we have X plus Y. equals 7 rather. And since in the second equation, we're told that y equals x plus 3, we can just take the y and replace it with x plus 3. And now when we drop the parentheses, we'll have 2x plus 3 equals 57. 2x equals 54 after subtracting 3 from both sides. And then finally, x equals 27 after dividing both sides. Once we know x, we can find y by substituting x into either of the two equations as follows. All right, now, of course, what you want to do is pick the easier one. So we know that y equals x plus 3. Therefore, y must equal 27 plus 3, and y equals 30. So that's all we need to know. In other words, one section has 27 students, the other has 30. Okay, and so that's it. That's all you had to do. There are other approaches as well. Now, here's one that you might have been exposed to, and I've asked around every time I teach this class. I ask people if they've ever seen this method, and almost without fail, people say no, they were not introduced to this. So let me just show it to you once. And just out of curiosity, I'd like to know if it rings a bell with anyone. What the logic here is, this is what you're doing. You would write them both in the same way. You line up the variables. So for example, this one, I could rewrite it as y equals negative x plus 57. Then I would write this one in the same way. And then I would add them together. Okay, so after adding them together, oh, somebody already recognizes it. You do? Okay, good. In the past, I've asked this same exact question, and I keep getting people say, no, I have no idea what you're doing. And so what you're going to get here is 2y, these cancel out, equals 60, so that y equals 30. And then from over here, if y equals x plus 3, that means that x equals y minus 3. X must equal 30 minus 3, 27. This is the method of simultaneous equations, it's called. All right, now I'm not going to say you must use one way or the other. I think most people, though, are more comfortable and familiar with the method of substitution. The advantage of simultaneous equations, though, is that it works well for very complicated situations where you might run into trouble with substitution. But with the questions we're looking at, the substitution method should work just fine. So I think what we'll do is, even though we know both systems or both methods exist, we'll focus our attention on the substitution method. On the other hand, if you're more comfortable with simultaneous equations, you can certainly feel free to use them. But if you've never seen that before, then don't even worry about it. Just whatever technique makes sense to you, that's the one you should be using. All right. Now, how about this one? We have Coke and Pepsi. Now, their combined revenues are 47 billion, but PepsiCo's revenues were 11 billion more than Coca-Cola. So how much revenue did each company have? Now, what we can do here is assign the letter X, let's say, to Coca-Cola. And by the way, if you do it the other way around, it doesn't make any difference. You'll always get the same answer, whether you call Coca-Cola X or Y. And of course, everyone's aware that PepsiCo is right across the street from the campus, at least when you're allowed to be on the campus. It's right over there. You can hardly see it, but the sign is right in front of you. So when you pull out of our driveway, you're staring right at PepsiCo's headquarters. They actually have this enormous sculpture garden there, which in the past you could just drive right in there and visit it. Now there's a lot of restrictions, but if you got nothing better to do one day, you might want to check it out. But anyway, so we're told that the sum is 47. And then we also know that PepsiCo is 11 billion more than Coca-Cola, which implies that Y equals x plus 11. Okay. And of course, again, there's different ways of doing this, but I think this is the most straightforward way to go. Okay, so PepsiCo's revenues were higher by 11 than Coke. And by the way, I happen to know that that's because of the snacks division. Apparently, they own Frito-Lay, and apparently the Frito-Lay division is more profitable than Pepsi itself. And I don't know if they appreciate that, but I know people who work there, and that's what they've told me, that the reason for this is because of that snacks division. But anyway, so now all we have to do is use the substitution method. We can replace y in the first equation with x plus 11. So x plus 11 was 47. 2x plus 11 equals 47. Subtract 11 from both sides. 2x equals 36. X equals 18. And then we can find y by substituting x into either equation. I'll choose the second one because it looks like it'll be quicker. Okay, 29. Okay, so Coca-Cola, we're at 18 billion, and PepsiCo, 29 billion. Now, of course, you can always double check your work too. And maybe you should think about it and note the sum of the revenues is 47 billion. And PepsiCo's revenues were indeed $11 billion higher than Coca-Cola. So that's how you know you got the answer right. In fact, instead of calling that note, let me just put double check. And this is always optional, of course, but I always think that double checking is a good idea. So in other words, when you get an answer, you look at it and say, well, does that satisfy the requirements? Why, yes, it does. There's only one way that can happen. Okay, just be aware, there's only one solution that can exist for both of those requirements. So if the numbers work, they work. Now, this number 3 is a bit of a challenge. You have to treat this one very carefully. The temptation, you've got the price of the car is $16,665.78, and the sales tax was 6%. So we want to know what was the price before the sales tax was added. So the temptation for a lot of people is to subtract 6% of the final price, but it doesn't work that way because the 6% was applied to the original price, not to the final price. So here's what we have to do. Or here's one thing we can do. X will be what we're going to call the retail price, which means price before sales tax. And let Y be the sales tax. These are both in dollars, not percentages, dollars. Okay, so therefore we know that X plus Y equals 16,665.78. And we know that the sales tax is 6% of the retail price. Okay, that's the key right there. The retail price is where the 6% is added. If you try to subtract 6% from the final price, you will not get the right answer because it's based on a different number. Now, again, using the method of substitution, we can replace Y in the first equation with 0.06x as follows. X plus 0.06x equals 16,665.78. Now I can combine these because they both have a common factor of x. And now I can divide. And by the way, because this is dollars and cents, you will need to round at the end. In other words, it won't be exactly a certain number of dollars and cents, so you can round it. 15,722.43 is your final answer for that. Now, it doesn't specifically ask for this, but we can also figure out what the sales tax was. All right, so the sales tax was, okay, so in other words, you don't need to do this, but I wanted you to see how this works. So we multiply that by 0.06, and that means the sales tax was 943 approximately. Remember, this is being rounded. And so if you add these together, this is your double check, by the way. So you add those together, 15,722.43 plus 943.35 is 16,665.70. Oh yeah, what do you know? It worked. Now, I do want to mention here, though, that when there is rounding involved, the sum of the retail price and sales tax could potentially be slightly off due to rounding considerations. It didn't happen here, but it's possible for this to happen. So when you get involved with rounding, sometimes you might find trivial inconsistencies because of the rounding. So just be aware of that. So in other words, if you got 16,665.79 or 77, you can be sure that that has something to do with rounding. Okay, rounding is kind of but I mean, you can see it's necessary because this is dollars and cents. All right, what else do we have here? Ooh, now here's one of these classic cases that you've seen these before, probably on the SAT that you took to get into the school. Pete is 3 times as old as Bill. The sum of their ages is 48. How old are they? All right, so let's just say X will be the age of Pete. Y will be the age of Bill. So what do we know about them? Well, Pete is 3 times as old as Bill, which means that X is 3 times Y. And in addition, the sum of their ages is 48. All right, so this time, why don't we try this? Using the method of substitution, we can replace Y in the second equation with, X in the second equation with 3Y. Now, this is not the only way we can do the substitution method, but I think it's the quickest. It says it right there. X equals 3Y, why not take advantage of it? So therefore, 3Y plus Y equals 48. 4Y equals 48, Y equals 12. Okay, and if Y equals 12, we can now find the value of X by substituting Y equals 12 into either equation. And of course, why not pick the first one? It's so easy. X equals 3Y equals 3 times 12 equals 36. Okay, so remember, X was supposed to be Pete. So Pete is 36, Bill is 12. Okay, so as a double check, Pete is 3 times as old as Bill, and the sum of their ages is 48. Okay, so we must have done it correctly. And we congratulate ourselves because, that was a bit of a tricky question. All right, let's see what do we have next. Oh, electric bills. Oh, how pleasant. Electric bills. So the electric bill for September is $232 less than the electric bill for October. Okay. Of course it is, because it gets colder in October. The total for the two is $119.56. What is the bill for each month? All right, let's try this. X equals September's bill, and Y is the October bill. We know September is less. So in other words, Y, you could think of it as October's bill is 232 greater than September, or the other way around. So why don't we do it this way? X plus 232 equals Y. In other words, we take our September bill and add another 232 to it. That brings us to Y's bill, October's bill rather, and then the sum is 119.56. All right, so using the method of substitution, we can replace Y in the second equation with X plus 232. And again, you know, there's several ways you can do this. The goal is to make it as simple as possible. Whoops. So we're replacing this Y with X plus 232. So it's X plus 232 equals 119.56. 2X equals, or plus rather, 232 equals 119.56. So now, of course, we're going to subtract 232 from either side. 117.24. And of course, now we're going to cut that in half. And we get 58.62. So therefore, we can find the value of Y by substituting X equals 58.62 into either equation. So let's pick the first one. 58.62 plus 232 equals Y. And when you add those two numbers together, you get 60.94. Okay, so we conclude from all this that the September bill is 58.62. Oh, I made a typo here. Sorry, this is Y. All right. So the September bill is 58.62. The October bill is 60.94. Okay, and you can see, double check. The October bill is 232 greater than the September bill, and the sum of the bills is 58.62 plus 60.94, which we add them up with your calculator, is 119.56 as we require. Okay. You can see they're all very similar to each other, aren't they? It's really always a question of first identifying two variables, setting up two equations, replacing one variable with the other, and substituting. So it's pretty straightforward once you get the hang of it. All right, now this next one gives a lot of people a lot of trouble, I've discovered through the years. So let's go through it very carefully. So this person has money to invest. Half of it was invested in some stock or bond or account of or other kind of investment that provided a rate of return at 8%. So it says at 8%. I probably should have clarified that a little bit. It's just they found an investment that provided them with a rate of return of 8%. It could be anything. It could be a money market fund. It could be a bond fund. It could be a stock that provides dividends. It could be anything. But she earned 8% on her return on her investment from that first half. The second half was 6%. Now, altogether, she earned $210. So Now here it mentions the word interest, so we'll assume that these are two different kinds of bank accounts which provided this kind of interest. Now, what this means is this. If you say that X is the first half of her money, and then Y is the second half. Now, what do we know? Well, we know that the total, well, we're looking for the total. Okay, one thing we do know is that since she invested half of her money in each account, then it must be true that X equals Y. Okay, in other words, the dollar value of her investment is the same in both accounts. Now, what about the $210 that she earned? The way we figure this out is we multiply the dollar amount invested in X, the first half. 8% is the return to that. For the second one, we earn 6%. And the total, therefore, is 210. Okay, in other words, what this means is the following. The first account, which has X dollars invested in it, provided a rate of return of 8%. Therefore, we can calculate how much interest this account paid by multiplying 8% by X. Now, here's an important detail. With mathematical equations like this, note, this is hugely important. With mathematical equations, percentages should be replaced with decimals. For example, 8% should be expressed as 0.08. If you multiply 8 by the dollar amount you invested, you're not going to get the right answer. So this 0.08x is meant to represent how much interest we earned from that first account. And then that implies that the second account, which has Y dollars invested in it, provided a rate of return of 6%. Therefore, we can calculate how much interest this account paid by multiplying 6% by Y. Now, I just realized I left something out here. There we go. Okay, and so therefore, total investment, the total earnings to this account, these two accounts, or the total interest paid to these accounts, is the sum of these two, adds up to $210 because they told us that in the problem. That's where this is coming from. So the two equations that we have are X equals Y and 0.08X plus 0.06Y equals 210. Well, now this one will be very simple to deal with because using the method of substitution, we can replace the Y in the second equation with X because they're equal to each other. So we'll have 0.08X plus 0.06X equals 210. 0.14x is 210. And when we divide out both sides by that 0.14, that works out, it's hard to believe, but it's an exact amount. 210 divided by 0.14 is $1,500. Okay, and since x equals y, y also equals 1,500. So she has invested $1,500 in each of the two accounts. Okay, so the double check is that the amounts invested are equal, and the total interest earned is 0.08 times 1,500 plus 0.06 times 1,500 is indeed, let's see, that's 120 plus 90 equals 210. Okay, so we must have done it correctly. Now, by the way, interestingly enough, the next chapter, chapter 8, is all about money and interest. So we're going to see more of this in the next chapter. Yeah, I know. Either you're happy or you're not happy. I can't tell which it is, but there'll be much more of this to come. All right. Let's see, what else do we have here? Oh, here's a sports. All right. Instead of money, we have sports. Now, what do we know here? The team plays 32 games, and they won 4 games more than they lost. All right, well, let's see what must have happened. Let's say that X is the games won, Y is the games lost. And we know 2 things, as always, otherwise we can't solve this. Oh, boy. Well, does anyone want to know the weather, for God's sake? This is Hartford, but still, this should be a pretty rough idea of what's going on at Purchase. You notice how the computer insists on it. I couldn't even stop it. All right, where was I? Here we go. Get that out of here. Oh, so we know that the total games is 32. And now we also know that the number of wins is 4 greater than the number of losses. So we could express this in a few different ways. Why don't we do it this way? Y plus 4 equals X. Okay, in other words, if you add 4 games to the number of losses, you'll get the number of wins. All right, now why don't we do this too? Using the method of substitution, we can replace X in the first equation with Y plus 4. So we'll have Y plus 4, Y equals 32. 2y equals 28, y equals 14. And now we can solve for X by substituting y equals 14 into either equation. Let's do the first one. It's so much easier. X plus 14 equals 32. X must equal 18. So in other words, the team won 18 games and lost 14 games. So for a double check, the total number of games played was 32. The team won 4 more games than they lost. All right, let's see, what's next? Ooh, this one looks interesting. So enrollments in classes. What do we know? All right, well, first of all, we're looking at 2 different years, 2017 and 18. So let's say 2017 enrollment, and Y is 2018 enrollments. So we are told that the total is 16,983, but sadly, the number decreased by 6% in the second year. So how can we express that? Well, let's just say that Y, and you notice how unlike the other examples, instead of telling you that it fell by X, let's say 100 students, they're giving you a percentage, and that really makes it even more challenging than usual. Instead of telling you that it fell by, let's say, some specific constant, they gave you a percentage. So what we're going to do is take X, and we're going to subtract 6%. Okay, so this can be rewritten as 0.94x. So what happened here is that the enrollment in 2018 were 6% less than in 2017. Actually, I'll put this down here. Therefore, Y is only 94% of X, or Y equals 0.94X. Okay, so that's how that worked out. So we have X plus Y is 16,983. And what else do we know? Y equals, let's see if I have any more space. I'd like to keep them together in the same place. I don't know if I have enough room. Let's see what I can do. X, Y equals 0.94x. So using the method of substitution, we can replace Y in the first equation with 0.94x. Okay, so instead of having X plus Y equals 16,983, we'll have X plus 0.94x is 16,983. We can consolidate these. Okay, because there's an implied 1 in front of this X. So X is 16,983 over 1.94. Now here we have to watch it because this is people. So our number has to be an integer. So the actual number is 8754.12. So we'll round it to 8754. This must be an integer because it involves people. Okay, so then we can find Y by replacing or substituting oh, I did it wrong again. X equals 8, 754, 12 into either equation. So let's use this one. All right, so wait, you know what? We're rounding it. I'll tell you what, why don't you use the rounded number? I don't think it'll end up affecting the results. You could leave it, but let's just do it this way. 82 rounded to 8229. Okay, so therefore 2017 enrollments equal 8754, 2018 enrollments, 8229. Now let's make sure that this works. Okay, double check. Total enrollments are 8754 plus 8229. Now, again, there's a possibility that they could be slightly off due to rounding, but it looks like not this time. 16,983, and the 2018 enrollments are 94% of the 2017 enrollments. So we're going to say that 8229, or what I should say is 8754 times 0.94 is indeed, with rounding, of course, 8229. Okay, so that one worked out. It was a little challenging, but we got it. All right, now Mary plans to, here we go. Mary plans to buy a used car. She wants to spend at most $8,000. The sales tax is 7%. There's also a license and title fee of $120, regardless of how expensive the car is. What's the maximum amount she can spend for the car? Now, what this means then, I guess I should have written this a little differently. What we want to know is how much can the retail price be? In other words, we know that she can spend $8,000, but that includes the sales tax and the license and the fee. What is the highest retail price that she can pay for this car? That's what it really should say, I guess. So how would you set this thing up? Well, if X is the retail price, the sales tax is 0.07X, and 120 is the license, title, and license plate fee. So the total cost is X plus 0.07X plus 120. And so this cannot exceed $8,000. So therefore, we can write this, okay? It can go below, but it can't go above. So it's actually an inequality then. So if we consolidate these two, we'll have 1.07X plus 120 is less than or equal to 8,000. Now, of course, I will subtract 120 from both sides. And so I'll have 8,000 minus 120, 7880. Now I just divide both sides by 1.7. And again, this has to be rounded to dollars and cents. So it's 76 or 73, 64, 49. Actually, it would, yes. You know what? I'll tell you what. There is a symbol. Watch this. Yes, but you're right. It would be. It's not a strict inequality. It's an inequality, and it does have the equal because she can spend $8,000, just not more. Let's see. All right. So there's a little trick for finding symbols in a hurry. Okay, 2264, watch this. Oh, I magically turned it into that symbol. How did I do that? First I looked at the code, and on the PC, if you type 2264 and hit Alt X, it will give you the symbol that you're looking for. The other option is to go into this box and spend a half an hour looking for it. There's so many symbols in here. It would have taken all day. Look at them all. You'd have to be incredibly lucky to find it like this, because there's no search engine in here. You just have to look. It's really kind of very clumsy and awkward. So if you find yourself writing a paper for one of your classes and you need a very unusual symbol, that's the best way to go. All right, so in other words, the retail price for this car cannot go beyond $73,64.49. Otherwise, the total cost will exceed $8,000. So the retail price, or sometimes it's called the sticker price. If you've ever been to a car dealership, you know they all have the big sticker on it. The new ones have to have that big sticker on it to tell you everything you could possibly want to know about that car, including a rough guess of what kind of mileage it gets. But so here, must not exceed $73,64.49. Okay. Now let's just double check. If the retail price is indeed $73,64.49, the total cost of the car, so we'll have the $73,64 plus the sales tax, whatever that is, plus 120. Okay, so the sales tax, 73,64.49 times 7% is 515.51. 515.51 plus 120. Let's add those up. $82. Oh, wait a minute. No, something went wrong here. What happened? Yeah, that can't be right. I think I multiplied something wrong. 73,64.49 times 7%. Oh, wait a minute. No. You know what I did? I just made a typo right here. I was going to say, what happened? 73.64. Well, that explains that. 73.64.49 plus 515.51 plus 120 is exactly $8,000. Okay, so that's good. She satisfied the requirement. All right, now here's Bill. Now we've seen something like this already in the notes. You get the 3 grades, and the final exam counts as 2 tests. Oh, this is a tricky one. This is not the same as what we saw, or not exactly. I mean, yes, it's similar. All right, so here's what we have to do. Let's let X equal the final exam score. Now, the final exam is being treated as if it were 2 tests instead of 1. So here's what we have to do. Bill's average will be, we add these together, and then we're going to count X twice and divide by 5. Okay, because we're pretending that it's 2 exams. And now he needs to get at least an A. I mean, at least a 90 to get an A. So we're going to treat, this is also an inequality, because it has to be greater than or equal to 90, this average. All right, so I'm going to have to look up that symbol. Okay, that's 2265. 90, there you go. So we'll consolidate these numbers in parentheses. 95 plus 84 plus 85. So it's 264 plus 2x over 5 is greater than or equal to 90. So now multiply both sides by 5. $450. So I subtract the 264 from both sides. 186. And therefore, X must be at least 93 for him to get his A. Now, in the double check, if Bill gets a 93 on the final exam, his average will be 95 plus 84 plus 85 plus, and then we're going to add 93 twice. Okay, so we'll add those up. 95 plus 84 plus 85 plus 186. That's 450 over 5, which is exactly 90. Beautiful. Nice. Now, here's Betsy. She's also taking a final exam, but she only needs a 70 because she's only aiming for a C. She's decided that C is good enough for her for this class. So therefore, she's just trying to figure out what she needs to get a 70. Now, here, we've got a 78 and a 68, but now all the exams are weighted equally. So this is Betsy's score on the final exam. So therefore, we know that Betsy's average will be 78 plus 68 plus X over 3, which has to be at least a 70 to get that C, to get that coveted C. So then I multiply both sides by 3. And then we have 146 plus X. X, therefore, is at least 64, okay? So she needs a 64 or better to get a C. So for the double check, if Betsy gets a 64 on the final exam, her average will be, all right, so she had, what was it, 78 plus 68 plus 64 over 3. Those three add up to 210 over 3, 70. Perfect. Nice. And then there's only one more word problem. The rest are algebraic problems, which I'm sure you'll be happy about. So a husband and wife want to sell their house and make at least a 10% profit. Okay, now that means based on the original purchase price. They'll have to pay a real estate agent a commission of 7% of the sale price, and they'll have to pay closing costs of $1,000, which is independent of the price of the house. Now, originally they paid $150,000 for the house. So what's the lowest price at which they can sell the house and still earn that 10% profit? All right, so there's a lot of things we can do here too. Why don't we just put X equal to sale price of the house. Now, we know that in order to make the profit that they're looking for, we need to have the sale price plus another 10% for their profit. Okay. Then they have to pay a 7% commission. Oh, actually, no, that's not right. You know why? Because we've already determined that the profit is based on the original purchase price. Okay, so the required profit, it's not 10% of the final sale price, it's 10% of the purchase price, which is $15,000. Okay, so real estate commission is that is based on the current sale price. So that's 7% of X, and closing costs are 1,000. All right, now we're getting somewhere. So to make all this work, they need the original sale price, they need the profit of 15,000, they need to cover that commission, and they need $1,000 to cover the closing costs. So it has to be at least let's see, it has to be, oh, no, that I've set it up completely wrong. X is the sale price. My fault, sorry. The original price, let's do it. All right, let me add one more thing here. The original price of the house is 150,000. So, all right, let's do it this way. Original price is 150. The profit they need is 15,000. The commission is 7% of the sale price, and the closing costs are $1,000. Now we've got it. Okay. So in other words, X, the sale price, has to be enough to cover all of these expenses. So in other words, the first 150,000 is to recover the original price of the house. The $15,000 is their profit. The 7% is the real estate commission, and 1,000 is the closing costs. Now it's set up correctly. All right, so X is got to be at least, now if we add the constants together, you'll see that that's 166,000. Okay, plus that 7% of X. Now let's subtract that from both sides. And you'll see that 0.93X is greater than or equal to 166,000. So therefore, X must be the ratio of those two numbers. And this can be rounded to dollars and cents. And that works out to 178, 494.62. That's close enough. Okay, so for the double check, if the price, sale price, is 178, 494.62, then the real estate agent fee or commission will be 7% of that, equals 12, 494, 40, 62. So therefore, if we subtracting the commission of 12,494.62 and the closing costs of 1,000, this will leave a net sale price of All right, so they sold it for 178, 494.62. They have to pay off the 2 fees. And so how much is left in their pockets after all that? 178, 494.62 minus 12,494.62 minus the 1,000 is 165,000. Okay, so this represents the initial price or the initial cost of the house plus a 10% profit, by which we mean 150 times 0.10 is 15,000. Okay, so in other words, their objectives have been reached. All right, so that means we must have done this correctly. So when the dust settles, the price is this number right here. They have to get at least this much to sell the house, cover their costs, and still make a 10% profit. Okay, but ultimately it was just this relatively simple inequality that we were solving. All right, now FOIL. All right, we know and love how to do FOIL, don't we? Yes, we do. So let's go through some of these FOIL questions. So the F would be x squared. In fact, let me do this one by hand. It'll be a little quicker. X squared. Outer is these two. Inner is these two. And last is these. So in many of these cases, not all of them, the O and the I can be consolidated with each other. So we'll have x squared. When you consolidate these two terms, you get minus 7x. And finally, you'll get minus 120. All right. So if you have a mistake, you probably made an algebraic error. All right. Let's try the next one. And they're all the same, of course. We have F, O, I, and L, x squared minus 3x (10x) minus 30. All right, so we have x squared. When you combine these, you get plus 7x minus 30. All right, very good. All right, what about this one? All right, so the F is here. Let's see. O is here. Minus 18x. I is here. And then here we have 63. 14x squared minus 67x plus 63. Beautiful. Oops. All right, let's go on to the next one. All right, here we go. (16x² minus 4x minus 4x again plus 1. We have to watch out for those negatives. So we'll have 16x² minus 8x plus 1. Okay? Excellent. All right, what about this one down here? So we'll have 15x² minus 40x plus 21x minus 56. Okay. I think we're all getting the hang of this. All right. And of course, you've already seen this before, but so these are very straightforward. And then finally, we have (6x² plus 16x). This is 16x minus 15x, and then minus 40. Yeah, that's it. Okay. Beautiful. Okay, now for the next batch of questions, we're going to solve these equations, but with factoring. Okay, so how does that work again? Let's see. So what we're looking for is this. We need, if you remember, we were writing this as x plus m times x plus n, which equals x² plus, see, using FOIL, we have first outer, inner, so we actually have m plus nx plus mn. So in order to solve for this, we need two integers whose product is 6, but whose sum is 5. Okay, so let's try to find that. So we can start by writing out all the pairs of integers whose product is 6, 1, 6, -1, -6, 2, 3, -2, -3. Now, of all of these, only one has a sum of 5, and that would be this one. So that means the factors are x plus 2 and x plus 3. But we want the solutions. So these are the factors. So what we're going to do is set them individually equal to 0. And then we'll end up with our two solutions, -2 and -3. All right, now let's say we decide to double check. Well, that's not the worst idea in the world. So we'll start with x squared plus 5x plus 6. And first I'll check it with x equals -2. So this expression equals -2 squared plus 5 plus 6. Okay, 5 times -2, that is, plus 6 equals 4. -2 squared is 4 minus 10 plus 6 equals -6 plus 6. That equals 0. So we're good there. Now let's try it again when x equals -3. All right, so we're going to have -3 squared plus 5 times -3 plus 6 equals 9 minus 15 plus 6 minus 6 plus 6 equals 0. All right, well, that's good to know. Now let's try this one. Oops. Now again, we need, just remember, we need a product of 20. And we need a sum of 9. So let's try factors that give us a product of 20. 1 and 20, -1, -20, 2, 10, -2, -10, 4, 5, -4, -5. Well, I think we have our answer right there. So 4, 5 is the only pair whose product is 20, but whose sum is 9. And so these are the factors, but we need the solutions as well. Okay, so sometimes it just asks for the factors. Here we do need the solutions, so it's pretty simple. Set these individually equal to 0, and you're done. Now again, the double check is not absolutely mandatory, but I think it's a good idea. It's not just that you're making sure you got the right answer, it's just that you're also getting more practice. Okay, so we'll have -4 squared plus 9 minus 4 plus 20 equals 16 minus 36 plus 20 minus 20 plus 20 equals 0. All right, let's see. Then we have -5. -25 minus 45 plus 20 equals -25. Oh, wait a minute. Yes, -20 plus 20 equals 0. Perfect. All right, now how about this one? So now remember, there's an implied 1 here. We need a sum of 1. We need a product of 12, -12. So let's try them out. 1, -12, -1, +12, 2, -6, -2, +6, 3, -4, -4, -3, +4. Of all of these, only one gives us a sum of +1, and that's this one. All right. So therefore, the factors must be these are the factors. And then, of course, to find the solutions, we need to set these equal to 0. All right. And then, of course, not that it's absolutely necessary. Let's double check. So we'll start with x equals 3. And we plug it in. And we hope to find that it's equal to 0. And that does, good. And then here we have a double check for x equals -4. All right, now -4. Plus -4 minus 12 equals 16 minus 4 minus 12. 16 minus 16 equals 0. Perfect. All right, so that confirms that one. Now here's another one. And so once again, here's the sum that we need. And here's the product. All right, so let's write out the numbers whose product is -10. -1 and 10, 1 and -10, -2 and 5, 2, -5, and that seems to be it, but we're done because we only need a sum of -3, which would be this one. You could actually, now that I think about it, I don't think we'll go that far, but you could confirm that these are the factors by applying FOIL to them. And you would find out pretty quickly if you did, in fact, correctly factorize it. So I guess we won't do that right now, but that's certainly always on the table. But then we're going to double check this. First, find the solutions, and then we'll double check them and make sure that they're working correctly. All right, so once again, I'll just double check both of these real quickly and make sure that these cause this function to be equal to 0. So -2 squared minus 3, -2, minus 10 is 4, minus 6, minus, plus 6. God, I almost blew it there. 10 minus 10 is 0. Great. Now let's double check again for x equals 5. 5 squared minus 3 times 5 minus 10 is 25 minus 15 minus 10. Okay, perfect. All right, now here's one that's a little interesting because if you notice, it's not in the traditional form for a quadratic equation, which requires ax squared plus bx plus c equals 0. So when you see something like this, what you have to do is rewrite it in that form. So this becomes x squared minus 14, minus 14x minus 51 equals 0. Okay, so in other words, the equation must be in the standard form, which I've shown above. All right, if not, you're going to get the wrong answer. In other words, don't start fooling around with it until you set it up properly. Okay, like here, for example, if you didn't notice that, you would have gotten it wrong because the sign would have been off. Okay, so in a case like this, go ahead and rearrange it algebraically to make sure it looks like this. Then you're all set. Okay, so now what we need is, as usual, we need a product of negative 51 and a sum of negative 14. So how would that work? All right, let's try some potential products of negative 51, negative 1 and 51, 1, negative 51, 3 and 27, negative 3. I think we're done because this, no, wait a minute. Oh, wait, sorry, my fault. That's not right. It's not 27, it's 17. And so we need negative 14, which we have here. These are the factors that we need. And then we'll set them equal to 0. All right, and so we may as well double check it. So start with negative 3. We get 9 plus 42 minus 51, 0. That one works. And then we'll double check x equals 17. So we'll have 17 squared minus 14 times 17 minus 51. Some big numbers here. 17 squared is 289. And then 14 times 17 is 238 minus 51, which is, 51 minus 51, it's 0. Woohoo. Okay. All right, let's do one more. I think we have time for one. Now, we're not going to finish. You can see we've got a little ways to go, but I'll tell you what we'll do. In spite of this, why don't we do the sample midterm next time? Next time we'll finish this, and then we'll do this as much of the sample midterm as we can. I think because people are getting anxious about the midterm. As soon as we're done with the sample midterm, I can give you the real thing, and then you can have time to work on it. I'd say I usually give out a week or so to give out. You don't need a week, but I'll give it to you anyway. You'll do it at home. And then the challenging part is you probably will have to write it out by hand because unless you're really good with an equation editor, and then you'll have to basically take pictures of it with your camera on your phone and send them back to me. So we have to get all that straightened out, but let's just do one more problem today and then we'll wrap it up. And on Monday, we'll finish this and the sample midterm, and then we'll be 100% ready for the actual midterm. All right. Now this one, if you notice, also needs to be rearranged because it's not in the proper format for a quadratic equation. So what we need to do here is simply subtract the 20 from both sides. and then we can get started. Okay, so we need a product of negative 20 and a sum of negative 1. Okay, so we'll start with negative 1 and 20, negative 2 and 10, negative 4 and 5. And so we need negative 1. That would be these two. So the factors are x plus 4, x minus 5. We'll set them equal to 0. Okay, and then we'll try them both, double check. X equals negative 4. Let's see if that adds up to 0. Negative 4 squared minus 14 negative 4 minus 51 is 16 minus or plus 56. Ooh, boy, something doesn't look right there, does it? Oh, no wonder, because it's not 51. It's wait a minute, I copied the wrong one. No wonder. It's x squared minus 20x minus x minus 20. Okay, that's a little bit more like it. All right, so a minus 4 squared minus 4, or minus 4 minus 20 equals 16 plus 16. Okay, well, something else is wrong now. Oh, no, this is right, because it's 16 plus 4 minus 20, sorry. Okay, minus 20, that's better. 20 minus 20 equals 0. Okay, all right, now let's do one more, and that's it. We're absolutely done. We're out of here. Double check with 5. All right, so same equation. All right, so 5 squared minus 5 minus 5 minus 20 is 25 minus 5 minus 20 equals 5. 20 minus 20 equals 0. Okay, so that worked. All right, so we'll save the rest of it for next time, along with the sample midterm. Don't forget about it. All right, and then we'll be truly ready for the midterm, which you'll do at home, not in classroom time, but at home. All right, so you know what I'll do? I'll post these, even though it's not complete, I'll post these on the Moodle, and then you can work on them or use these to help yourself get ready for the rest of these questions and the sample midterm. And then on Monday, we'll finish everything up. All right, so if there's no last minute questions, I will see you all on Monday.
Thank you.
Thank you. Have a great day.
Okay, bye.
Have a nice weekend, Professor.
See you.
Thank you, Professor.
See you later. Bye.
Professor,
Yes.
I just wanted to let you know that I had a death in my family, so I'm going to be leaving the country.
Okay.
But I will follow up with an email just to let you know. Like,
Good.
I don't know if I'm going to have Wi-Fi where I'm going because it's a remote country.
Right. Okay.
It's a third
Right.
world country, but I'm going to do my best to still find a way to get the midterm done on time.
Okay. All right, I'll tell it. Yes, definitely send me an email to remind me. And then if you can't get to Wi-Fi, that's okay. I'll give you extra time to take care of it.
Okay, thank you so much.
Okay, you're welcome.
Have a good one.
All right, you too.